let's say that there's a 50-day period in between blood tests. Day 1 blood test, day 50 blood test. So if you're tracking your dietary intake, if you're tracking your average daily heart rate as a measure of how physically active or how much stress, that cumulative stress, if you take that 49-day average in between blood tests, that then lines up with the latter blood test. So now each blood test has a set of variables that align. So now you blood test another 50 days later. Now you have 2 sets of data, 2 49 or 50-day groups of data that you can compare, just even using a 2-sample t-test. And for variables that change, you can just go across the board, macros, micros, supplemental intake, HRV, resting heart rate, pick your variables of interest to see what's different in the inputs and what's different in the outputs. And maybe there are 10 things that have a nominally significant difference, p-value less than 0.05. Nonetheless, there are going to be some things that are going to be different. And then you have some hypotheses. Okay, albumin went up. These things changed. Is it causative? If it's causative, if I keep them high, let's see what happens. All right, so then going from 2 tests for the next 50-day period or however many days in between tests, using that same approach, for each subsequent test, you have those inputs because you're tracking them, the average intake for the full period. Now you have 3 tests, and even though 3 tests isn't a lot to look at correlations, you can still get a ballpark idea of stuff that may be related. Stuff that's completely unrelated, the correlations will be flat, and there may be there's obviously not a lot of noise in that data, but that's basically the guts of it. Tracking, lining up the blood test data with the inputs, with whatever you're tracking. After 2 tests, 2 sample t-tests, after 3 tests, looking at just simple correlations. And then, as I mentioned, adding another layer of statistical rigor. For some things, I have 2,000 data points, right? Like HRV, resting heart rate. And because I've tracked body weight and a whole host of other metrics, knowing that body weight is a big, it's strongly correlated with both HRV and resting heart rate. If I'm looking at other factors that may be involved, I adjust my model. So I don't just look at simple correlations. I look at, multivariate adjusted linear regression models, which sounds like a fancy thing, but it's just one step beyond the simple correlation. So that's the approach that I've used.